Hello, this is Dr. Oz. Today I would like to talk about decision analysis. Decision analysis is an important component of business analytics, and if you remember, the definition of business analytics is making better business decisions using data. So based on this definition, as you can see, the most important component I would say here is decisions. So we are trying to make better decisions and use data. So decision analysis is therefore an important component. So let's take a look at the introduction part of it. Again, we talk about business analytics about making better decisions. Making better decisions. And we are trying to develop an optimal strategy and choose between different decision alternatives. And if these decision alternatives are not provided to us, we need to come up with them. And the risk is an important component of this decision-making process. For example, state of North Carolina use decision analysis evaluating medical screening tests to detect disorders in newborns. So should I do it or not? What are the outcomes and so on? The idea here is to provide probabilities and understand favorable and unfavorable outcomes. And reasonably, we would like to have a few decision alternatives, not so many, for the future events. And the topics that I would like to discuss here in decision analysis is payoff tables, and decision trees, sensitivity analysis, and I will show you how to use Bayes' theorem. Let's talk about payoff tables and decision trees. So the first step in decision process is to create a verbal statement of the problem. Then we would like to identify decision alternatives, and we would like to call these uncertain future events as chance events. There will be some uncertainty in our model, and there will be some outcomes associated with the combination of decision alternatives and chance event outcomes. So let's take a look at this example. Pittsburgh Development Corporation, PDC. They have 3 different projects. One, 30 condos. Another one is 60 condos, and the last one is 90 condos. And the financial success here depends on the size and the chance for the demand for these condos. So here are the decision alternatives. Again, we define a problem up here. Our problem is to maximize our return considering the risk. And here, decision alternatives is how many small, how many medium, and how many large complex should we go to, or produce, or create, or buy. So in decision analysis, the possible outcomes for chance events are the states of nature. States of nature. And the states of nature are mutually exclusive, meaning that no more than one can occur. and also collectively exhaustive. Meaning that at least one must occur. So overall, one and only one of those should happen. For this example, condos have two sets of nature, either strong demand or weak demand. Okay, so these are my chance events. So let's take a look at this payoff table. If we go with small complex, D1, and if there is strong demand, I will make $8 million profit. However, if I go with small complex and weak demand, I will only make $7 million. For example, large complex, if the demand is strong, I can make 20 million instead of 8 million. However, if things go south, I will lose $9 million. So let me just take a screenshot of this data, because I will build my models based on these numbers. All right, so I take the screenshot of this so that I will develop my model based on this. So payoff is the outcome resulting from specific combination of decision and the state of nature. For example, this is a payoff, $7 million. If I make decision small complex, which is D1, and the chance of weak demand, I will end up $7 million. Payoff table is showing all the possible payoffs. So the table up here, 3x2 matrix, is my payoff table. All right, so we will use the notation of V sub ij, and here V sub ij denotes payoff associated with decision alternative I and state nature of J. So that's why V sub 3(1) is 20, because if you look at the row 3 and column 1, you will see that it's $20 million. So that's it for this video. Until next video, enjoy business analytics.